Hey, hello, hi dear Swift learners. How are you all? I hope that everybody is fine, and I welcome you all here at Swiflearn, which is India's most sincere learning destination where you get the classes for grade 1 to grade 10. You will be getting live and interactive classes over here with personalized attention batch of maximum 6 students, and apart from teachers we have academic mentor team to track your progress and to guide you through the same. Also at Swiflearn we cover the syllabus as per your school exam schedule so that you can perform well in the school also. And apart from these, there are some of the key features like detailed progress report. Then we have Swiflearn academic test series and unlimited practice test, which include 2 categories of subjective and objective. So all these things, please experience yourself by booking a free trial class. And if you are new to the channel of Swiflearn, kindly subscribe it and press the bell icon so that you do not miss any update. And if you like the video, press on thumbs up. Now we are going to study about organic chemistry in today's class. We have already done first session in which we learnt about what is meant by organic compound, what is organic chemistry dealing with, and what are hydrocarbons. So we have learned the basics of organic chemistry in our first session, and if you have missed out on that part, kindly check the Swiflearn channel. The videos are listed there and please go through it. So today what are the things that we are going to cover is nomenclature, the alkyl and functional groups, and isomerism. Let us quickly start. Now if I ask you how many of you have nicknames, I think almost everyone we have our nicknames, right? So when we were born, our parents, they gave us a name which is a kind of official name, which is there in every document in our school and for every official word. But at home we are called by nicknames by our parents and our loved ones, right? For example, if a person's name is Shobit in school, that becomes Shobu, Sonu, Sona, etc. in the family. So similarly, we have given some of the nickname to the carbon compounds also. So these are known as common name, and then we have official name like we have, which are known as IUPAC names. So let us see what is common and what is IUPAC name. What happened was in earlier days when the compound's name, it actually depend from which source are we taking those compound. Okay, so such names, they were known as either common name, their nickname, their trivial names, right? For example, if I talk about CH4, its nickname or the common name was marsh gas. And why it was named as such? Because it was obtained from marshy places. Similarly, if I talk about citric acid, so citric acid, it was named after botanical source citrus. So since we got it from citrus sources, and that is why we named it as citric acid, right? But these common names were not systematic. So what we needed was, we needed to systemize this process, and that is why there was a need of proper nomenclature of chemical compounds. Okay, now if I talk about nomenclature, what is meant by nomenclature? A chemical nomenclature is a set of rules to generate systematic name for chemical compounds. So what is nomenclature? Actually we are having a set of rules to give the name to different chemical compounds. Now to name organic compounds, the IUPAC nomenclature it is used. And what does IUPAC stands for? It is International Union of Pure and Applied Chemistry. Okay, so this nomenclature becomes very systematic and it is followed all over the world. It was systemized by the chemist of IUPAC in year 1957. Now, according to this particular system, there are some of the rules that we must follow to name any molecule. For example, the first thing is word root, the second thing becomes suffix, and the third thing becomes prefix. Now what is each of these we are going to see. Word root. Now word root, it actually depends on how many carbon atoms are present in the longest chain that we are selecting. Okay, If there is one carbon atom, the word root becomes meth. If there are two atoms, it becomes ETH, eth. 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 stands for noun, and 10 for dec. Next is suffix. So suffix is any word which is added after the word root. So the suffix, it actually represents the nature of bond in carbon and carbon atom. For example, if there is a single bond between carbon atoms, the suffix becomes "ane." If there is double bond, the suffix becomes "ene", and triple bond, the suffix goes like "yne". Okay, for example, there are 4 carbon atoms. Okay, and there is single atom. So from word root, it will be but plus ane. So it will be named as butane. If we replace it as double bond, so it will be but plus ene, butene. And similarly for 3 bonds, it will be butyne. But instead of these, if we are adding any group, so alkyl group, so it will go like alkyl. For example, methyl, propyl, hexyl, etc. Next is the prefix. So prefix means pehle. So it denotes the substituent such as alkyl or functional group and its position in the carbon chain. Now here see 5 carbons are present. Okay, so this becomes our longest chain, and since at the position of 2 one group is added and the group is methyl, so we will be naming it as 2-methyl. Okay, why? Because methyl group is added at the second position. Now let us study a bit about alkyl group. So alkyl group, how it is obtained? By removing one atom of hydrogen from any alkane molecule, CH4. Okay, now the structure of CH4, it looks like this. Now what if I replace this hydrogen by any group? Let's say the group is X. So here this group becomes alkyl group. Okay, so it is obtained by removing one atom of hydrogen from alkane molecule, and the formula goes like CnH2n plus 1. So there are various alkyl radicals like methyl, 1 carbon atom, so methyl goes like CnH2n plus 1 CH3, ethyl C2H5, propyl C3H7, butyl C4H9, etc. Okay, so here from methane we are removing one hydrogen atom, which gives the alkyl group, which is methyl. Now give the name of 3 alkyl group and show how are they formed. So we can take example of methyl, ethyl and propyl. Methyl, it consists of 1 carbon atom and 4 hydrogen. What we need to do? We need to subtract 1 hydrogen atom, so it goes like CH3, which becomes methyl. Similarly in ethane, it is C2H6. If we subtract 1 hydrogen atom, it goes like C2H5, ethyl. And propyl, it is obtained from propane by subtracting 1 hydrogen atom from it. Now, what do we call an atom or group of atom which defines the property of any family of organic compounds? So these are the functional groups. What are the functional groups? These are any group of atom which have a very important role in deciding the function of any compound. The various function groups that we have is alcohol, aldehyde, ketone, carboxylic acid, halides. Now talking about the prefix and suffix of the same, alcohol, it goes with suffix OL. So if we add methane plus ol, it goes like methanol. Similarly ethanol, propanol we have. Then aldehyde, CHO, and the suffix is AL. So we have butanol. Next ketone, so ONE is the suffix, propanol, butanol, etc. Carboxylic acid, methanoic acid, ethanoic acid, that is the suffix. Then we have halides, which are fluoride, chloride, bromide, iodide, and prefix is also present, fluoro, chloro, bromo or iodo accordingly. Now we're going to understand this concept of functional group through a short video. So we will be seeing it and then we will be discussing it.
In this introduction to organic chemistry, you will learn the definition of a hydrocarbon and how functional groups give molecules similar properties. Organic chemistry is the study of carbon compounds. There are many millions of organic compounds that you can make using hydrogen and carbon and arranging them in different ways. Hydrocarbons are defined as compounds made of hydrogen and carbon only. The simplest hydrocarbon is methane. It consists of one carbon with 4 covalent bonds to hydrogen atoms. The next in the series has 2 carbon atoms, and this is called ethane, and is followed by propane and then butane, these being the names of the first 4 in the series of molecules called the alkanes. Pause this video now and try to draw the structure of hexane. Hexane has 6 carbon atoms.
Now if I talk about hexane, it has 6 carbon atoms, and now what we need to do is we need to fulfill the valency needs. So here 1, 2, 3 hydrogen atoms will be added. Here 2, again here 2, here also, and here we will be adding 3 hydrogen atoms. So here all we are adding hydrogen atoms to fulfill the valency needs, and this is what becomes our structure of hexane. Alright, let us move forward.
Here is the structure of hexane. Compare it to the structure you drew. Did you get it right? The next series is called the alkenes. These are hydrocarbons that contain a double covalent bond between 2 carbon atoms in the molecule. Just like the alkenes, each carbon atom still needs 4 bonds, but has 2 bonds already due to the double covalent bond with the other carbon atoms. The ethene molecule is completed by 2 more bonds with 2 hydrogen atoms for each of the carbon atoms. These also follow a pattern, and the next molecule in the series is propene and then butene. Pause this video now and try to draw the structure of hexene. As before, hexene has 6 carbon atoms.
So here hexene will have 6 carbon atoms. There will be one double bond and other will be single bonds, and accordingly we will be satisfying the valency needs by adding hydrogen atoms. Let us see how.
Here is the structure of hexene. This time there is a double bond because it's an alkene. The video tutorial on the alkanes and alkenes will give you more in-depth knowledge on the bonding and structure of these series of molecules. As we have already discussed, hydrocarbons are molecules containing only carbon and hydrogen atoms. However, the study of organic chemistry includes any molecule with a carbon backbone. Functional groups are groups of atoms which give molecules similar properties. There are many different functional groups. You may have heard of the alcohol group. This is a hydroxyl group and is a hydrogen bonded to an oxygen, which is then covalently bonded to the rest of the molecule. This group can be attached to any of the alkanes to form alcohols, their name all ending in -ol. For example, methanol, ethanol and propanol. Pause this video now and try to work out the name of this molecule. There are 4 carbon atoms in this molecule with an alcohol group, and so its name is butanol. The alcohol functional group means that all these compounds will react in a similar way and will have similar properties. Carboxylic acids are another example of a functional group. This is the functional group for a carboxylic acid and gives an organic molecule the name oic acid. Methanoic acid, ethanoic acid, propanoic acid and butanoic acid. There are lots more functional groups. Esters, which give molecules a sweet smell and make them useful for perfumes and flavourings. Ketones, which make molecules useful as solvents. Amines, which can be used as dyes and useful in making medicines. Some molecules have more than one functional group and give molecules different properties still. Now, by the end of this video, you should know that organic chemistry is the study of carbon-based molecules, and that hydrocarbons are molecules containing hydrogen and carbon only. You should also know that functional groups are groups of atoms which give molecules similar properties.
Okay, so I hope you might have understood everything that was being told in this particular video. Now we will be moving forward, in which we will be learning a bit more about these functional groups and about organic compounds. Now let us study the rules of nomenclature of organic compound, which means how to name any organic compound. We have to be following certain rules. And what are these rules? Let's have a look at it. First rule is selection of carbon chain. So we are expected to select the longest carbon chain, okay, and then we are naming it as a derivative of alkane. For example, if we have two cases here, okay, so if I select this chain, I will be having 5 carbon atoms. Next, if I select this chain, I will be having 4 carbon atoms. But if I select this particular chain, so the number of carbon atom becomes 7, and this is the correct one. Why? Because in the nomenclature we have to select the carbon chain which consists of largest number of carbon atoms, and then we have to name it accordingly. So we cannot select like 5 or 2 or 4 anything. We have to select the chain which is having maximum carbon atoms. Next rule says that the branch chain are considered to be substituents, and their positions are indicated by number of carbon atoms to which they are attached. For example, if I am having 5 carbon atoms here and there is one group, methyl group attached, so I will be seeing at which number it is attached. It is on second carbon, so I will be naming it as 2-methyl. Why? Because methyl group, it is added to number 2 carbon atom. Next rule, the numbering of carbon atom of the longest chain should be done in such a way that substituents get the smallest possible number. Now, in this example, we are having 5 carbon atoms in this also and this also, and there is one methyl group added to one of the carbon atom. Now there are two ways of naming. Either we can name it like 2-methyl or 4-methyl. But what does our rule says? That we should name it such that the alkyl group, which is the methyl group, it should get smallest number. So abhi we are having smallest number as 2. So that is why this method becomes correct instead of 4-methyl. Next, in case of presence of any functional group in the chain, the carbon atoms are numbered in such a way that functional group gets the smallest possible number. Abhi, if we are having alkyl group also and functional group also, so our priority will be the functional group. So here what we are expected? We are expected to number it from here to here. Why? Because यहाँ पर alcohol it will come on second number, but here alcohol is coming on fourth number. So since functional group priority is greater than alkyl group, that is why we will start numbering from here. So that is why it is named as 4-methyl pentane 2-ol. And when we are adding a suffix of ol, what are we doing? See, pentane, it is pentane. So what we are doing, we are removing this e to add ol, pentanol. Okay, so in nomenclature e of alkane, it is replaced by suffix of functional group. Next rule says that if different type of substituents are attached to the chain, then arrange the name alphabetically. For example, if we are having bromine also and chlorine also here, so B comes before C obviously, so that is why we name here as 2-bromo, 4-chloro and hexane. So we go like alphabetically. The position of alkyl group, they are indicated by writing position and name of alkyl group just before parent hydrocarbon. Okay. Next is, if multiple alkyl group are present, then we label it by prefix such as di, tri, tetra, penta, hexa, etc. Okay. And for alkyl group on same carbon, the number is repeated. For example, see here, we are having one methyl group and another methyl group on same carbon atom. So we will be starting numbering from here, obviously 1, 2, 3 and 4. Abhi we are having 2 methyl group, so we will be writing 2 times 2. Or 2 methyl group hai, we are having 2 methyl group, so we will write di, methyl, and how many carbon atoms we are having? 4, so 4 goes for bute, and since there is single bond everywhere, it will butane. Okay, but if here in place of this the structure is like this, CH3 CH3, and one is here and the other is here. Okay, so here the name will be 2, 3. Okay, so why? Because the positions are changed here and the rest part will be same. Now we have studied about rules of nomenclature of organic compounds, and we are going to see how to write structural formula. Now for writing formula, again we need to follow some of the steps. Write the carbon atom number according to the word root. So if it is given 2 bromo, 4 methyl pentene, so first take this word root. Pent means 5 carbon atoms, add it. Now start the numbering from any end, because right now we have not done anything, we have just written the names. Next, abhi hame kya hai? We know that 2 per bromo hai, 4 per methyl hai, and 2 per again ene, that is double bond hai. So we will go like, first we will be adding a double bond from 2. Okay, since it is ene, and if it is yne, add 3 bonds, and if it is ane, that is alkane, just add 1. Then attach the substituent or any functional group which is mentioned. So 2 chloro, 4 methyl. Okay, so that is how we name it. And finally what we need to do is we need to satisfy the valency by adding hydrogen atoms. Okay, so here we are adding, so CH3, so 3 hydrogen atoms are added here also and here also accordingly. Now let us make some molecules and try to know their names. Okay, so I will be picking up, let's say 3 carbon atoms. Then we are going to add hydrogen atoms here. So see, prop 1 in. So how is the structure here? Okay, then we have 1 and 2 here. Abhi what is happening? 1, 2 and 3, only 3 valency is being fulfilled here also and here also, so we need a double bond here. Now how does name happen? First of all, number of carbon atom, it is 3, so 3 prop. Abhi we are having double bond at first position, so 1 and then ene for the double bond. Okay, next. Okay, so here it is ethanol. Why? Because 2 carbon atoms are there and the functional group is there, right? Let's do one more. Now we will be adding 1 atom. So 2-chlorobutane. Now see here, the numbering started from this side. Why? Because functional group, here it is getting number 2, or here it will be getting number 3. So we will take minimum number possible, and that is why it is named as 2-chlorobutane. Alright, so let us move forward. What are the compounds that have same molecular formula but different arrangement of atoms with respect to one another? These are known as isomers. So what are isomers? These are the compounds which have same formula but their structural arrangement it is different, okay, from each other, and that is why it gives a change in their physical and chemical property. So this formula, this phenomena, it is known as isomerism, and we are going to learn a bit more about isomerism in this video.
In this video, you will learn about structural isomers of the alkanes, what structural isomers are, and be able to give examples of isomers. Here are the formulae of the first 4 alkanes: methane, ethane, propane and butane. And here are the structural formulae of the first 3. Pause the video and draw out the structural formula for butane. I expect most of you have drawn a straight chain molecule like this. However, there is another way of arranging the atoms. It has the same molecular formula but a different structural formula. These 2 forms of the molecule, C4H10, are called structural isomers. The longest chain in this molecule is 3 carbon atoms long, so we say it is a form of propane with a methyl group sticking to the second or middle carbon atom, so its name becomes 2-methyl propane.
So see, in the previous example, what we saw that we are having, just a minute. I'm sorry, just a minute. Yeah, so in the previous video what we saw that first structure that we can draw is just by adding 4 carbon atoms in a straight line. But what if we do not add them in a straight line and if we add a group in the middle? So this leads to a change in the structure, and because of this change in structure, what happens? The property also changes. Alright, let us move forward.
Do not be confused, it is still an isomer of butane because of the 4 carbon atoms. To make it easier to draw these structural formulae, we often omit the hydrogen atoms and just show the bonds connecting the carbon atoms, bending the chain so you can see where the carbon atoms are. Before we try to find more isomers, here is the story of lead-free petrol. Petrol for cars is mostly octane, C8H18. In the 1920s, when petrol started to be used for cars, the petrol-air mix in the cylinders used to explode too quickly before the spark, causing the engine to knock or jolt. If an isomer of octane was used, the petrol burnt more smoothly. Look carefully, there are 8 carbon atoms, so it is a structural isomer of octane.
So here see, the circles are representing the carbon atoms. So we are having 1, 2, 3, 4, 5, 6, 7, 8. But here it is not a straight line, okay? So this particular change in structure, it leads to change in the properties, and that is what is meant by isomerism.
But what is its formal name? Pause and count the atoms in the longest chain. Whichever way you count, the longest chain is 5 carbon atoms long, so the name will be pentane. And off the 3rd atom in the chain, there is an ethyl group and also a methyl group, so its name will be, pause and think, 3,3-methyl ethyl pentane. But this compound is not normally found in crude oil and is very expensive. In 1923, scientists discovered a compound of lead with almost the same structure and did the job perfectly: lead tetraethyl or tetraethyl lead. You might remember that lead is in group 4 of the periodic table along with carbon. The lead addition helped the petrol to burn smoothly, but the lead atoms combine with oxygen, forming lead oxide. This comes out of the exhaust pipe as a fine dust and is very toxic. It has taken us until this 21st century to get rid of all the lead in petrol globally, but for 80 years lead from car exhausts has been carried around the world and is even found in the ice in Antarctica. So let's finish with a simpler example. Can you find the other 4 isomers of hexane, C6H14, and give them their formal names? I'll give you a hint. There are 2 based on pentane and 2 based on butane. Pause whilst you try to draw them out. Here are the hexane isomers with 5 carbon chain, so they are named pentane, 2-methylpentane, 2 because the methyl group is on the 2nd carbon atom in the pentane chain. Not the atoms, 6 carbons, 14 hydrogens, it's still hexane. And here's the other isomer based on pentane, 3-methylpentane. And there are 2 more structural isomers based on butane, with only 4 carbon atoms in the longest chain, 2,3-dimethylbutane and 2,2-dimethylbutane. So from this video you should know that structural isomers have the same molecular formula but different structural arrangement, and that naming is based on the length of the longest carbon chain and on where the groups come off this chain.
Okay, so we just now saw what is the isomerism, what are the properties, and how do they show different structures. Now let us see how different type of isomerism is possible. So there are 2 type of isomerism, structural and stereomerism. So stereomerism, it is also known as space isomerism. It is based on geometrical isomerism. And in structural isomerism we are having 4 types: chain, position, functional and metamerism. So let us study about each one of them. Chain isomerism. What is happening in this case? 2 or more compounds, they are having the same molecular formula, but their arrangement, it is different in maybe straight or branched chain. So that is chain isomerism. Okay, so here we have pentane. It can be named as neopentane. Okay, same carbon atoms, 5 number, but the structure is different. Position isomerism. In this, what is happening? 2 or more compound with same molecular formula, they differ in position of substituent atom or functional group. So here they are known as position isomerism, position isomers, and this phenomena, it is known as position isomerism. How does it happen? See, but 1-ine, but 2-ine. So it is just the position of the triple bond which is changing. Here also but 2-ene, so it is starting from 2nd number carbon atom, and here it starts from 1st. Next is functional isomerism. So in functional isomerism, the compound formula is same again, but functional group is different. Like we are having here OH, which is alcohol, and here we are having OCH3, which is ether. Okay, so the number of the molecular formula, it remains the same, but the arrangement is different. And metamerism, it is the process, or here the compound, they are having same formula, but the number of carbon atom, it is different on each side. See, for example, here both of these are ether, right? This is also ether and this is also, but here the number of carbon atoms on this side, and here it is different. Okay, so here that goes for metamerism. Now there are some of the facts. The alkenes like ethene, propene, butene, they are colorless gases, and if alkene, it has 15 or more carbon atoms, it becomes solid, and if it has between 5 to 15 atoms, it is a liquid. So what are the things that we have learned today? We learned about nomenclature, alkyl group and functional groups, and isomers and their types. So now we are going to do a small activity to see what we have learned. Draw the structures of following compounds. So first is butanoic acid. So butanoic acid means first of all 4 carbon atoms, and next is COOH group. So it will be like 1, 2, 3, 4. Okay, and so this particular carbon atom, it will have this functional group oxalic acid, oic acid, and then we will be just filling the valencies here to satisfy the valency need. Okay, so this becomes the structure of butanoic acid. Next, talking about heptanone, so it is the functional group which is here is ketone. So heptanone means 7 carbon atoms. Alright, I'll just draw it here. Okay, so first of all we have drawn these carbon atoms, then we will just fulfill the valency needs. And here what are we doing? We are doing the ketone group. Next is pentanol. So OL, it's alcohol. So again pentane, 5 carbon atoms. Okay, and then what are we going to do? We are just going to add OH group and fulfilling the valencies. So this goes for pentanol. And at the last it is chlorohexane. So again 6 carbon atoms. Okay, fulfill the valency here and add chlorine to the first group. Okay, so I will be adding Cl here. So here it will be CH2, and all the carbon atoms will get 2 hydrogen atoms to fulfill their need of valency. Alright, so yeah, these are the things that we have covered today. I hope that you might have understood every single thing that we learned in this particular class. We will be meeting in the next class, in which we will be learning a bit more about these carbon compounds, isomerism and hydrocarbons. So keep studying, keep learning. Let us meet in the next session. Thank you everyone.